Hey, welcome back. Today on the bench I have a Sansui integrated amplifier. It's an AU519. It's a heavy beast. It was brought to me by a client. He wants a full service restoration type service, and this is the note he gave me. The black Sansui hasn't been plugged in since I salvaged it from a garage sale. I have no idea if it's operational or not. I'd like to have it clean, checked for stability, ideally restored if possible. Okay, looks good. This is very nice condition. A little bit of scratching on top. The paint is scratched up quite a bit actually, but the front face is pretty much pristine except for a few scratches here. It's very dirty. You can tell it hasn't been used in a while. The dust on the knobs, and looks like there's some water staining on that knob. So it's probably wasn't stored in the best conditions, probably in a garage. Or see, here's another water stain on a knob. I wonder if they're all like that. I don't know. But we'll get into it and we'll get this thing humming properly. This is a nice amplifier, really well built. It's heavy. Yeah, so I'm itching to get at this one. This is going to be fun, I think. So, what are we going to do? We're not going to plug it in yet. We're going to take the top off, have a look inside, just to make sure. Here's one note for people that are maybe not familiar with these Sansuis. These side screws here, these are M4 screws. Now we got two different lengths. The bottom one is a short screw, it goes at the back. The long one goes on the front, because if they have the rack mount ears, that's what they want the long screw for. So that's what that's all about. Okay, before we get into the insides, let's have a look at the front. So it has a nice sticker here, original Sansui sticker, DD to DC circuit, I don't know what that is. Power switch, nice chunky one, phones, speaker selected for two sets of speakers, and then we have our bass and treble controls here. Tone, defeat, or tone on. Subsonic filter is 16 Hertz for rumble, turntable rumble. Loudness button. Super Fidelity DD to DC. I don't know what that means. Something interesting. There's a attenuator volume knob and a balance control here underneath. Two tape monitors and a source, and then you get to copy from one source to another, or one from one source independent of what you're listening to, I guess. And then you have your input selector, two phono inputs, a tuner, and an auxiliary. So it's nicely laid out. All the controls you need actually. So let's have a look at the back. Alright, on the back we have our grounding lug for a turntable, two phono inputs, tuner, auxiliary, two tape loops, preamp, power amp in and out, and then we have a switch here to disconnect them if we want to separate them. We have a choice, direct coupled or capacitor coupled. Yeah, look at that, that's an interesting device there. We can, so you got one of four positions here: connected, direct coupled, capacitor coupled, and separated. Yeah. Banana plugs for your output speakers, and three courtesy outlets and some cobwebs. Alright, take the cover off. Looks very good. We are in. Look at the dust on this thing. So that's the first order of business. It's going to take it outside and blow this dust out of it. It's been sitting for quite a few years, a few decades actually. Now he said he was scared to power it up. Wasn't sure if it was a wise choice. We'll go through and we'll do a few checks here. I've got these big heat sinks. Our power transistors are down the bottom there. So I think if I pull the bottom off, I can do a continuity check on the or a diode junction test on the output devices, and that'll tell us right away if it's shorted or not, and if it's safe to plug it in and turn it on. So let me get the bottom off, and let me get this dust out of here too. I don't want to start spreading dust all over my bench just by moving things and touching things. So I'll get this cleaned out. Alright, got it back in the house now. Got a little bit of wet on it because it's raining outside, but let's have a look. So dual power supplies, so that's good for a performance standpoint. Got each channel has its own independent transformer, rectifier, filter capacitors. so that's good. This board here in the center, I believe, is a power supply board. It looks like it's got all kinds of heat sinks and capacitors on it. We have two power output modules, and these look like they can be removed independently. There's 4 screws that holds them in, and I think they can just be unplugged from underneath. I'm not sure. We've got our connection boards in the back. We'll check those. Oh, you can't see. We'll have to check all this for crack solders, which is, I think I can already see some here. Yeah. This board on the side here looks like PhonoStage, and it's quite big too. There's a lot going on here. It looks like there's quite the PhonoStage, so we're going to get into that. So here's all our tone circuits. We have our bass and treble on a separate PCB board that can come out, and we can surface the pots easy. And then all down here looks like preamp, preamplifier. We have our tone, subsonic, and loudness switches here, and everything else is on this board. It looks like it's very well laid out. Attenuator style volume knob, and our function switch is a long shaft that goes to the back. The switch is right here. That's good too, is from a point of keeping noise down. And here's the underside. Yeah, I was right. You can unplug each module. So remove each module and simply just unplugging them. And here's our transistors. We're going to check these 4 transistors to make sure none of them are shorted. Very easy to service this thing. Here's the bottom of the phono board, and then let's pan up. Got the bottom of our 4 filter caps with our star grounds in the center. Bottom of our power supply board. So everything's very modular and easy to service. So I'm going to just start taking things apart and recapping. I don't know where I'll start. Probably start on the power supply board. That's usually where I like to start, and go from there. But first, let's power this up, see how it works. Let's check these devices before we power it up. Everything looks good. Okay. No shorts. Let's try this side. Very good. There's no shorts in those output devices. I can't see any reason why we can't just put some power to this thing. Before we do any work, let's do some baseline readings. So we've got it connected to an 8 ohm load and 1000 hertz tone. Let's put it to the test. Okay, we got our volume minimum. Here we go. Can you see that? I hope so. Went up to 116, 117 watts there. 40 watts idle. Clicked on. Clicked on. Let's try it. We get any volume here. We've got one channel, and then the other channel decide to join us late. Fix this up. Looks like we've got a channel imbalance here. Oh, we're clipping already. Let me adjust this. Okay. Looks like we have really poor switches. This switch here is really bad. Helps if I set them for both the same. There we go. Okay, now we're in business. There's our clipping. Clipping on the top before bottom. Let's measure what we're putting out. We're going to measure the left channel. Okay, so I'm going to measure it right from there. And get 27.14 volts RMS. Let's do the other channel just to be fair. Okay, here we go. Okay. 27.12. I think it's the same. Even though they are not quite tracking together. But that's not a concern right now because we're going to replace all the caps and everything's going to change. So I just want to get a baseline. Everything's working good except for switches. Look at this switch. That's the tone of defeat, I think. And this is a loudness. It's dirty. All these switches are dirty. Tape monitor. Function switch. It's dirty. Balance pot is dirty. Very dirty. Treble. Dirty. Everything's dirty. Bass. Oh, that's a sweet speaker switch. Speaker switch. That's dirty. Bass. Yeah. All the pots and switches are going to need cleaning. But let's start by doing a recap. So just a little bit of testing here. This is quite hot. And these are cold. So we got a good runner here. This is a good amplifier, I think. This is going to be really worth putting some money into and bringing back. We're going to get this going good. So here's a look at the protection board and power supply board taken out of the unit. I found it easier just to take it out and then I can work on the bench. And yeah, so this has 3 sections. It might not be totally apparent, but there's a line here. That's one section. This is power supply. There's a line here, and this center section is all protection for the amplifier. The relays are removed, and then the other power supply on this side. These 2 power supplies are identical, and I think I'm not sure what they supply, but I think they supply the early stages of the power amplifier with clean, regulated, rectified DC. Now, I'm going to pull all these caps out and replace them. 2 of these caps are bipolar. These are 220 microfarad, 6.3 volts, non-polarized, and the rest of them are just regular caps. Don't see much circuit glue going on here, although there is some down here at the bottom of these big black ones, and I'll remove all that. So as far as this goes, there's not much to talk about. There's a couple transistors here. Is an A726. Let's see here. I saw another one. There's another A726. Alright, so the power supply protection board is complete. I recapped and I replaced 4 transistors. Went through and cleaned the back. Have a look at this. Supply. Power supply. It is a power supply too. So they're not power supplies. Anyways, I had the relay out, tested the contacts, and yes, these contacts typically were around 20 ohms, 25 ohms, somewhere around 50. There's 4 sets of contacts in here, and they had them paralleled up, 2 for each channel. Did the usual, took it apart, cleaned it, polished the contacts, and I brought the contact resistance down to about 16 milliohms, 17, 14, somewhere around there on all of these. So it's a lot better. So this one's ready to go back on. I can snap this cover back on. And we can put this back on the board. So this board is done. just need to solder this relay back in, and can be put back into the receiver. So here's the main tone amplifier, tone board, preamplifier, whatever you want to call it. It has the bass treble controls, the volume, balance pot, and it has the tone switches. And it all comes out as a unit. You got to unplug one connector, two connectors, and desolder 4 wires from the back, and the whole thing comes out as a unit. Now I'm going to recap this, but I've been looking at it, and I've been looking at Sansui schematic. A lot of these capacitors here are actually back to back. So this pair of capacitors here, we've got two 10 microfarads at 25 volts, but if you look on the board, they're wired in series. So what they're doing is they're making a non-polarized cap out of two polarized ones, and they do that 4 times on this board. These two capacitors here, or is it these two? I'm not sure. These two, and these two. So what you can do, these are two 10s at 25 volts. I'm going to remove these two 10s and put in a 4.7 non-polarized cap in its place, and that'll reduce the parts count and increase its reliability, I think. Instead of having 2 caps, you're just going to have 1. And I'll do that for these two, and then these are 100 microfarad at 10 volts, and these are placed back to back. So you can replace those with a 447. I don't think I have a 47 bipolar cap. I'll look and see if I do. I don't think I do. I think 22 is the largest I have right now. Alright, so here's one of the two power amplifiers. I believe they're both identical, I think. So if you mix them up, left and right, I don't know if it makes any difference. I don't think it does. Just a few notes on this power amplifier. It's only got 2 devices. These 2 driver transistors here have the emitter lead cut off, right? So they're relying entirely on this screw connection through the board to the back to make the emitter or the collector connection. So that's something you got to keep in mind. Make sure that it's insulated from the heatsink, but it's not insulated from the screw, so that the current can go through the screw into the back side of the board. 2 adjustments. This one's bias, this one's your DC offset. Now they put a couple of test probes or a couple of pins up on top of the amplifier you can clip onto, and this is for setting your bias. Access this when this is all installed. Makes it easier because these emitter resistors are down at the bottom. This is the chassis level, pretty much right here. Alright, so I finished with this board. It's pretty much done. It's cleaned up. A little bit of dust left on the transistor. I should brush that off. All the caps are changed, and I've gone through and resoldered any dodgy looking connections and cleaned up the board. So this is ready to go back in. Another thing I've also done is I soldered these nuts to the board. I just tacked them on one side, and that'll provide a good electrical connection. Yeah, that's pretty much it. There's not much else to say. Everything went good. Everything's good here, so it's ready to go back on. The heat sinking, I was looking at this, is kind of dried up. It is actually very dried up. But we can replace this stuff. So what is this diamond differential that Sansui is trying to sell us? I'm not really sure myself. It looks like it's just a bunch of more differential pairs that they put in the amplifier. So let's go through the amplifier layout and see what we can figure out here. So this is one, it's called like a block diagram of the output side, one channel. Here's our output going to our speakers. So right here's our 0 point for our 2 power devices. Here we have our input. It goes into a dual FET transistor. I think this is a 2SK129 dual FET, and this is your first differential pair. So you have input on one side, and you have your amplifier negative feedback coming in on the other side. And here we have a constant current source for the pair, and I think that's pretty much it. And then from there it feeds into what they call a pre-drive circuit. No, sorry, the diamond differential. Yes, the diamond differential. So both The positive going side and the negative side has a differential pair, and it's made up of 4 transistors, 2 PNPs, and no, hang on here. These are all PNP transistors down here, and these are all NPNs. Okay, starting to make sense. Now they have input signal comes in here, goes through this FET, comes up and over and into this transistor, into this long tail pair, and from here we have our negative feedback, which comes in here and goes this side. Okay, so they're doing it double. I don't understand why they're doing it double, but for whatever reason they figure this this is superior. And then from our diamond differential we have our output signal that goes into our pre-drive circuit, and I think this is just like a Class A amplifier that provides voltage amplification and goes into our drive circuits with our bias control in the center and our bias adjusting transistor in the center. So why am I showing you all this? Well, on this amplifier we have these 4 transistors here are NPN, and these are 2SC 1313s, and they're on my naughty list for being high failure rate, problematic transistors. So what we want to do is we want to upgrade these to something that's more modern and more reliable. We're going to need to match pair these, match these two and match these two, and we should be good to go. I intend to replace these transistors with KSC 1845s, and they should provide good service. I'll have to look at the voltage ratings here. This is 49 volts here, and see we have a plus minus 50 volts, 51 volts. So I have to be cautious of that voltage rating on all these transistors. That's what they call the diamond differential. Never heard of that one before. And they kind of carry the same topography into the other amplifiers as well. Let's look at the phono stage. Okay, here's a look at the phono stage. This is one amplifier shown. So we have our 2 phono inputs, and we switch between them. It goes into a FET. They use the same 2SK129, I believe this is. Where does it say this? Yeah, 2SK129 right here. And it goes into this differential. And they have a current source here for this pair, and from this it goes into another differential pair, which is powered by 2 2SC 1313s, which I'll need to replace as well. And from there it goes into voltage amplification and then output stages. It's kind of like a little mini power amplifier, but it's only intended to amplify phono signals, really small 2.5 millivolt signals. And from here, this point here, they pick off the output and run it through the RII equalization filters, and it goes back into the other FET as an input, negative feedback, and that's how they do the curve. So basically the same thing, except they don't have the diamond differential. They just have a FET differential and a silicon transistor differential, and they run these in tandem, looks like. And yeah, it should be a very good clean phono stage when it's running properly. So I have to look for, I'll probably replace these with KSC 1845s as well. Here's a look at the preamplifier tone amp. What they call it, a control amplifier, but it's your stage that amplifies your line level signals and provides your bass treble controls and all that other stuff. So here we have our inputs, switches, goes into a differential FET. Again, we have the 2SK129 dual FET at the beginning, and then it goes into a transistor differential pair or long tail pair, current source, and then it goes into voltage amplification, and it goes into your output pairs. It's basically the same topology as the other amplifiers. 200 microfarad DC blocking caps in series, because they're trying to build a bipolar cap there, I believe. And then it goes into switching, more switching, and then it goes out to the power amplifier, the output here. Feedback comes from, where does feedback come from? Oh, I think this is your tone defeat switch. Because if we switch this down here, we're including the tone controls and the filtering for that. And it looks pretty complicated for a tone circuit. Usually these are pretty basic, but it looks like they're employing a differential pair and maybe some amplification. Lots going on here. So yeah, Sansui put a lot of engineering and thought into this. So they wanted to make it good. So let's see here. We also have transistors here. 2SC1313, transistor 1 to 4. To 4. Where's, okay, that's the other channel. 1, 2, 3, 4. Okay. And 13 to 16. 13, 15, 16, 17. Okay. So I'll have to replace these two and these two as well, because these are the problematic 2SC1313s. And we'll get those out of there. So we got quite a few transistors to replace. Thankfully they're only about 50 cents a piece. Okay, so what I've done is I've gone through and I hand matched 12 transistors. I got 4 over here. These are matched pairs, and these will go into the phono stage, so I'll put those aside. And I have 8 transistors here that are all matched together. They all have the exact same gain, and these are going to go in here. There's 8 transistors that need to be replaced. 1, 2, 3, 4. And then there's 5, 6, 7, 8. So there's going to go through and replace those 8 transistors. Now I'm pulling out perfectly good transistors, replacing with other perfectly good transistors. You're probably asking, why are you doing that when the amplifier is working fine? Everything was fine when we first tested it. There was no problems. But these transistors have a history of failing, and I want to replace them because, you know, as soon as I ship this back to the client and he starts using it full time, let's say for after a couple weeks, a month maybe, it might fail. And this is what I'm trying to prevent. I've had lots of failures of transistors after the equipment's been put back in service and used for a while, and then it starts going through this thermal cycling again, and yeah, it's unavoidable. There's nothing you can do about it. It's going to happen, right? And there's no way to predict it. So there's a little bit of preventive maintenance. These transistors are cheap. You can get them. I buy them by the hundreds, and yeah, they're a good substitute. So I'll get through, warm up my iron, and I'll get through replacing those 8 transistors, and then we'll get to the phono stage and we'll replace 4 more. And one more thing, these transistors don't have the same pinout as the originals. These are actually reversed. These are emitter base collector, and the ones on the board here are, let's see if I can get a look at one of these. 1313. I have base, emitter, and collector will be the center pin, obviously. So these are all going to be turned in backwards. It's going to look funny, but it's going to work. Alright, so we got 8 transistors replaced, and a few other things done here. We have full recap, and I think that's all I've done. Well, I've actually cleaned switches, pots, and yeah, replaced transistors. I don't know if you can see this, but here we have 200 microfarads, and these are actually wired in series. If you look on the board, and they do the same trick over here. 200 microfarads wired in series. They had 2 10 microfarads wired in series here, and I replaced it with a single 4.7 and jumpered the other one, so that this is a bipolar cap and another bipolar cap here. The only reason I put 2 caps back in place because I didn't have a 47 microfarad bipolar, and if I had those I would have replaced it with a single cap instead of having them back to back. My thought is having 1 cap instead of 2 is 50% less chance of failure. So that's my thinking, and that's nothing to do with today. We're talking like 15-20 years from now, when these caps start to age, and the chances of failure are less. Everything else has been replaced and serviced, cleaned the backside, and it's all ready to be reinstalled and ready for testing. Alright, we're on the home stretch. We have our power board reinstalled, our tone board reinstalled, our phono input boards reinstalled, everything's put back. Now we got some work to do before we can get this thing going. Notice we have no power amplifiers yet. I left those out for a reason. Now, the reason is we have to adjust 2 potentiometers on this board and do a zero balance on these 2 amplifiers. And if I put the power amplifiers in place, you won't be able to get it, add them with a screwdriver. So I left those out for a reason, yeah. So but first I want to confirm I have all my power supplies. We've got, how many power supplies we got? 6 different power supplies. So we have to make sure they're all working. And let's turn this thing on for the first time. Everything's connected, I believe. Alright, so we have our, can you see this? Let's turn this on. Jumped up to almost 100 watts, and then we're still at 41 watts. And the relay clicked on. And it was at 40 watts, but now it dropped down to 20. Something happened. I don't know what that's all about. We had smoke. So we blew up something in our power supply. Great. So let's do some troubleshooting. Actually, first let's see what we blew up, because this is not good. Try this again. Okay, we have 52 minus 52. That's pin 11. Pin 11. So pin 9 should be plus 52. See here. Plus 52. Pin 11 is minus 52. Okay, that's correct. Pin 10 is plus 59. Or sorry, plus 50.9, and we got 53. Pin 12 is negative. Rail voltage, we have that. Okay. Pin 15 should be plus 30. I think those are over here. Plus 30. No, plus pin 15. Pin 15 is on this side. And we got our plus 30. Okay. Pin 19 is negative 30. So this one here. And we got our negative 30 on that one. Pin 16 is plus 30. That one's dead. So we don't have our plus 30 on this side. And pin 20 should be minus 30. Okay, so we're missing our plus 30 supply on this side. And our positive 30. Let me look at the schematic and see. Alright, so I tracked it down to R106 being open. That's the part that opened up under heavy current. That's a 100 ohm resistor, half watt, and it's a flame proof resistor, I believe. So I'm going to replace that resistor. I checked this transistor, it's fine. It's got no shorts, no hard shorts. And I'll check the polarity of these capacitors. I'm pretty sure they're in the right way. Well, this one would make a difference. This one wouldn't. But I think what's going on here is I have a short somewhere on this D feed line for the phono stage and the tone amplifier. So let's repair this resistor, and we'll get this going without any load, and then we'll figure out where the short is. Okay, replace the resistor. Let's test this out with this disconnected. This is the tone board, and I also pulled the plug on the phono stage too, so that they should be both disconnected and there should be no load on this, and we shouldn't pop any more fuse resistors. Have to be careful here. This is 120 volts back on this side here. This is all live, so just got to be careful and aware of that as you're working on live circuits. So we have it plugged in. Let's turn it on and let's see. Drops down to 16 watts. Relay click. No smoke, which is promising. Get our voltmeter happening here. Here is, let's try this again here. This should be 0 volts. Can you see that? No, you can't. How about that? Is that better? Let's try this one here. Negative 31. Okay. And our line 16 should be plus 30. And there it is, 31 volts. Okay. So obviously we have a short on one of those printed circuit boards. Let's plug one in at a time, see what the current draw goes up. I'll plug this one in quickly and then we'll unplug it. This is the tone amplifier. Let's see if I can get this. Hang on here. It's at an awkward angle. Here we go. Got bent pins here. Now, only shot up to 21. I heard some sparking that kind of freaked me out. 21 watts. So that shouldn't be our problem right there. That should be fine. Our tone board is not overloading. So that leaves the phono stage. So let's plug in the phono stage and see if we have a short here. Here we go. I'm watching the meter. Oh yeah, it goes up to 40 watts from 21. So yeah, we have a short on our phono stage, so we'll go after it there. Okay, here's the phono equalization stage. Got one amplifier here, one amplifier here, and I already see my mistake. The way these boards are laid out, if you look, each capacitor has a plus and a line on the negative. Now, if you look at this capacitor, I don't know if you can see that, there's the line coming out from underneath. Can you see that line coming out from underneath? And here's the negative. Look at this one. Here's the line coming out from underneath, and the negative's on the opposite side. So this caps in backwards. That's my mistake. This one here, got the line and the negative on this side. That one's correct. So that's our short. That's what happens when you put a cap in backwards. It hard shorts power supplies and causes mayhem. Now I'll take that cap out. You can turn it around. It's probably fine, but what I'll do is I'll just toss it in the garbage and put a new one in, because it's been reverse polarity, and it might be damaged inside. So we'll get rid of that, put a new one in, and then we're good to go. And I'll check some of these other ones too, make sure they're all 100%. Must have had a brain fart when I was doing that one. So here's that cap I pulled out, and it tests out. It's a 220 at 35 volts. It tests out at 204, and it's got a high ESR now, 770 milliohms. It should be down around 170 milliohms. 220 at 35, yeah, 170 milliohms. Let's get a brand new one and try it. So here's a brand new one. Again, same capacitor, same brand, same batch, and we got less than half the ESR now, and the microfarads a little better. So putting reverse voltage on electrolytics does damage them, so you want to get those replaced, not continue using them. Alright, now that I got that repaired, let's try one more time. Let's confirm our 30 plus minus 30 volt supplies. Power meter there, let's turn it on. Drops down to about 23, 22 watts. Relay clicks in. Everything sounds normal. Okay, so what was our numbers again anyway? We had, so our numbers were 15. Oh, here, let's check 16. 16 was dead last time, so we got it back. So that's what we got here. 30.4, and pin 20 should be my negative supply. Minus 30.3, everything's good. This side here should be negative 30. And lastly, why have I got nothing here? What's going on? Pin 15. There it is. Okay, they're all good. Now, on to adjustments. So we have to set the 0 point on all these amplifiers. We have 2 amplifiers in the phono equalization stage that need a 0 adjust, and they are adjusted with VR01, VR02. VR01's here, there's blue, and there's blue one back here. And there's test points on the back side of the board that the factory soldered on for us. We can clip onto them. Let's do this one first. Let's turn on our meter. Let's go for millivolts. Okay. Hope you can see that. Yes, let's turn this on. Let's turn this down. Looks like we have 0.4 of a volt here on this amplifier, which is not good. So let's zero this one out. Do they say anything about... There's no warm-up time, but this is drifting quite a bit, so let's try and zero this. Wow. Okay. Let's try and get this. It says plus or minus 50, but it's very touchy. And it's drifting quite a bit too. This screwdriver is not very good. That's better. Super touchy. Let's see how I like that. Get it close to 0 again. There. I'm gonna let that stabilize. Let's do the other channel. Clip onto it. This is not bad. 7 volts. Holy. Not a big fan of this meter. When it changes ranges, it goes 0, 0, and it kind of confuses me when I'm taking my readings. You watch when it gets around by 20, it drops and goes 0, 0. Okay. Let's turn this up a little bit. Wow, so finicky. Hey, we got 8 millivolts. It says plus and minus 50. Okay, let's leave that one alone. Let's go back to the first one. 130. A lot of drift on this side. Just put my finger on those FETs and it just... Well, we'll see how it goes. I think that's going to be good for now. Now we get to do the same thing for our tone board. There's 2 amplifiers on here that need to be balanced as well. Okay, to adjust the DC balance on the tone amplifiers, there's 2 test points on the board. They're really hard to see. One is down, and we get a pointy device. One is down here beside this big thick green capacitor, and it's marked TP. It's a little post, it's gray, it's hard to see. And then there's another one. Where is the other one? The other one's right here. Between this transistor and this capacitor, it's marked TP. So let's do the top one first. Let's clip onto this. And that's 8.4, 8.3, it's dropping. And they want plus or minus 10 millivolts on this one. So let's leave that alone. That seems okay. Let's try the other one. Oh, that's even better. 3.5 millivolts. I'm not going to adjust those. No, I'm going to leave that alone. I think that's good. The phono stage though needed adjustment. Now we need to do our power amplifiers. So before plugging in the power amplifier modules, notice we have 24.6, 24.4 watts of power we're consuming. It's sitting at idle. Alright, power amplifiers are installed. What I'm going to do is I am going to only connect one. Fire it up and see, just to make sure we don't have any other shorts. So we got this one on, let's turn it on. Jumps up to 30 watts from 24. Relay clicks on, everything sounds good. 32 watts. I'll let this discharge and then I'll connect the other amplifier. So wait till these drop to 0. Well, this side is discharging, this side is not discharging. Still at 30 volts. We'll wait till this goes to 0 and then we'll connect that amp. Okay, so it's safe to connect now. So let's connect this here. This here. And our power. Alright. Turning on. 37 watts now. Relay clicked on. 38, 39. Okay, so let's do a bias adjustment. I'll let this idle for about 5-10 minutes and then we'll do our bias adjustments. Alright, so this thing's been sitting on idle for about 20 minutes. Actually, it was in the other room, I forgot about it. So let's go back and let's check our 0 balance on our output power amplifiers. And we got a millivolt scale here. And we'll do one channel at a time. I'm just going to pick it off the speaker protect relay. And let's connect one channel. And we got 19 millivolts, so we can adjust that down to 0. Let's see here, get a screwdriver. Flip this around. And which amplifier we're doing? We're doing the one on the left here. This amplifier. So we want to adjust the blue pot. Oh, you can't even see. This amplifier here we're going to adjust first. The blue pots are 0 adjust. The white pots are your DC or your bias adjustments. Sorry. Okay. So we have 19. We're going to get this close to 0 as we can. Let's turn this. That goes the wrong way. Let's turn it down. Too far. Oh boy. It's very fussy. Okay, let's try this again. I had it at 1. 1.8. See if we can get it bang on. Woohoo! 1.3. No. I'm going to leave it at 1.3. That's good enough. Let's measure the other channel. Let's flip this around and I'll adjust. This connects here. 6.4. It's pretty much perfect. But it's better. Okay. Alright, so our bias adjustments, we want our amp warmed up, which it is. Millivolt meter. And we have these clip leads so that they're easy to clip onto this. So we have to clip this on here. Positive to positive, negative to negative. You don't have to hook them up right. But our target here is 20 millivolts, plus or minus 1. So let's get our power meter in frame here. You can see that up in the top corner. Let's turn down this amplifier. It's a little too high. The white trim pot is our bias. So I have to go from this side. Turn this down a bit. I'll put it down to 19. There, close enough. I'll let that stabilize. I'll come back to it. Okay, let's do this side. $21. This one's better. Turn this one down a little bit. Oh, this one's really touchy. 19.5. Notice our consumption dropped probably 2 watts after we made that adjustment. I'll just go a little lower just because it's going to drift up again. Right there is fine. Let's check the first channel again. It's still a little high. I like to put it on the low side of the range. There, 19's fine. Alright, we're done. Let's test it. Alright, so let's get the test out of the way here. We're wired in for a power test. Got an 8 ohm load, 1000 hertz tone, and you should be able to see the scope on the screen. So let's turn this thing on and see what these beasts can do. Text comes in, and we're drawing 38 watts. So let's turn this up a bit. Wow, there's our clipping. Both channels equal. Back it off a bit until the clipping stops. Right about here. That's kind of an unusual clipping waveform. Okay, so let's peek it out right there. And we are running at 27.06 volts RMS on the output, and we're consuming 333 watts. And you can see that. Yeah, you can. So let's let this cook for a while. And looks like it has no troubles whatsoever making that power. Totally silent, there's no buzzing coming from the transformers. Everything looks good. So we'll just let this go for a while, and I'll come back. I'll bring you back when there's something to say. Okay, this has been... shut the fan off. Okay, this has been going on for 10 minutes now at full power. These are just starting to get warm to the point where I can hold my hand on them. So they're probably about 55 degrees, 60 degrees. But we're going to turn this down. I had to add a fan to my dummy load to cool that because it was cooking everything around it. But that amplifier is solid, and I don't know, this will probably go all day. It's not even that warm yet. 10 minutes, full power, I suppose, but who listens to music like that? Okay, let's do a few other tests here. Let's look at some square waves. Kind of curious on how that looks. Okay, there's 1000 hertz square wave. It's actually looking pretty good. I think that's really good. Let's try, this is a treble cut, treble boost. Oh, we got a little scratchiness there in that pot still. I'll have to address that. Bass boost, bass cut. There's a balance pot. It looks good. This is loudness. Let's turn that down a bit. Wow, it really boosts the highs and the lows. Okay, this one here is subsonic. That's a 16 hertz filter. No effect. What happened here? Went into protect. I clicked on the tone circuit. We lost one channel. Okay, we've obviously got something wrong with the tone circuit here. This looks like it's pushing DC onto the signal line, and that's causing the amp to freak out. Let's shut down and check this out. Alright, so I ended the test early because we ran into a fault condition here. And the condition is, when I manipulate the tone control to defeat tone control here, it appears to be placing DC on one of these two lines. One of these two lines goes out to the power amplifiers. Right? Any DC on these lines will translate into a large DC value on these power amplifiers, and that's what's causing the protected trip in. So before I start condemning anything here, let's check a few things. We can check for voltage right on these two output lines. Right here and here, pin 22 and 21. I got a voltmeter here, you can see. So let's go pin 21 first. Let's turn it on, and we're going to get weird voltages as everything stabilizes. There's a relay clicked in. We got 0 volts there. Let's try pin 22. Got 0 volts there. Okay. So now if I click the tone is on, the tone controls are on right now. If I press defeat, see that jump in voltage? And the relay clicked, and it clicks back on again. Okay, that's the gray wire. Let's do it the other way. Let's turn the controls back on. And we got a tiny amount. Okay, let's do the other channel. Pin 22. Let's turn the controls, tone controls off. See, we got 0 volts here. Relay click back on. Turn the tone controls off. No, put the tone controls back in circuit, and nothing happens. So we're getting DC on one channel, this gray line here. I don't know which one it is. I think it could be it's one or the other. Let's see here. Let's check on this switch. Okay, so we'll test here. We got nothing. I test on this one. Nothing. This one here. And we got 0.5 volt. And this one here, we got nothing. So this line here is applying DC onto our outputs. Let's go look at this schematic. Alright, so what I did is I went with a voltmeter and I checked around this switch here, S02A and 02B down below. There is a single pole double throw switch. Now this one selects between no tone controls and tone controls, right? This is what the switch does. It goes between the two. And I was testing on this switch. I was getting no DC on pin 2, but on pin 1 I was getting that 400 millivolts or something coming through this DC blocking network here. What they have is 200 microfarad caps back to back to provide a 50 microfarad non-polarized capacitor, and then they have a 220 nanofarad bridging that as well. Now this test point here, I have been measuring it, and it has DC on it at the oddest times. So there's a flaky connection here somewhere in this circuit. I'm beginning to think maybe it's a bad FET, or it is the trim pot maybe bad, because I did set it and zero it. Now we're getting 400 millivolts. So I'm going to go after this trim pot here and have a good look at that, because I suspect that is going south. Now what's even making this more frustrating is it's not doing it all the time. It's doing it less and less now that I'm playing with this. So I don't know if I think I have a bad component here somewhere. But see, right now I'm measuring. There should be a DC voltage building up on this line when it isn't now, because I guess from me poking at it, see, it's just not there anymore. One channel is fine, the other channel has a DC on it. Just need to determine where this DC is coming from. So I think I might start, I don't know, it'd be nice if I could just pinpoint this. Now it's not acting up at all. Alright, I'm still trying to figure out this mystery. It's come back again. It comes and it goes. So right now I have 400 and some millivolts. The thing is, when I connect my meter, it drains the voltage. So watch, when I connect it, it shoots up and then it drops and drops. Now whatever the impedance of this meter is, 10 megohms or whatever, is causing that voltage to bleed off. So if I follow this, there's a jumper here from here to here, and then I get the same voltage across the other side of the jumper, and then it goes to a resistor. Let's see here, I'll show you. I'm right here right now at pin 1 of that switch. Now it goes to this R38, which what is R38? It is a 220 ohm resistor, and then it goes to this capacitor blocking network here, and there's R36 here. This is supposed to be 100K, and this should bleed off any voltage that I have to ground, but it doesn't seem to be. It seems to be there, and then when I connect my meter, let's see here, where is the spot again? This is the spot where 100K is. There's the voltage, and then it bleeds down. Here's the other side of the 100K, and I believe that's ground potential. I'm thinking that 100K resistor is bad, but I did measure it in circuit, and it measures 100K, so I'm going to pull it out and replace it and see if this nonsense goes away. Alrighty, I replaced that 100K resistor, and it's made no difference. The mystery to me is how is this little junction point between these 4 or 5 components getting 400 millivolts? It's a mystery, because it's surrounded by a ground trace, and there's no other way. Well, there's a voltage there. See, if I measure it, it's 0.3 volts. If I measure the test point, it's 0, which is what it's supposed to be. I measure at the test point, it's 0. I measure here, it's 0.3 ohms. And this voltage is definitely coming from in here, not from externally. It's not coming from this, because if I measure that, it is 0 as well. See? There's ground. There's the other end of the 100K resistor with that phantom voltage coming from somewhere. Okay, I think I'm finally making some progress here. I put the voltmeters away and pulled out the oscilloscope, and saw a different story. So let me explain what I'm doing here. I'm going to probe right here between this capacitor and this resistor, and this shunt resistor to ground. I replaced this. Pulled these 2 caps out, tested them, everything's fine. Pulled this cap out, tested, everything's fine. So right here I'm going to put the oscilloscope probe, and I'll show you what I found. Okay, here we go. There we go. We have an oscillation at 10.3 megahertz. Who would have thunk we had an oscillation at 10 megahertz on this this amplifier. So we have to figure out what to do about that. Alright, so like I just showed you, I probed right here, this point. You got a 10 megahertz oscillation. Now, I'm not really sure how to deal with this. I have a feeling there's a 33 picofarad capacitor here, and that's to shunt any high frequencies. I'm thinking maybe adding another one here to shunt any feedback. I don't know if that's going to make any difference. Or I could take this capacitor out and monkey around with the values. I really don't want to do that though, because that could upset the frequency response. Whatever we do here, we have to be careful. They have 2 picofarad caps here and here, and a 22 here in series with a 6.8K. This one here is providing, let's see here, this is our feedback path, but this one's providing a lower impedance path for high frequencies. Is that what they're doing here? Huh. Anyways, I'm gonna have to figure out how to quelch this oscillation. So I could do a number of things. 10 megahertz shouldn't be hard to get rid of it. Just add a capacitor somewhere. It should quelch it. I'm thinking I'll try this first. I'll add one here, and then I'll try adding extra here, and I'll see what the difference is between those two. Alright, so I'll tell you what I did here. I added a I added a capacitor right here. And it's a 25 picofarad. Now, the oscillation is completely gone. So I'm wondering if maybe 25 picofarad a little too high. Maybe I could turn it down to a 10 or a 15. I want to minimize the effect of anything going on with the amplifier's action. I don't think it's going to do anything. It is in the feedback portion of this long tail pair. That might affect frequency response, so that's what I'm worried about. So maybe I'll turn this down, but here I'll show you where it is on the board. Just tacked it on here between the gate connection. I don't know if you can see it. This gate connection here of the FET and this ground trace here. So that's where it is, and it works. So I don't know. Well, we'll have to go back to doing amplifier testing. Let's go back and check. Actually, what I'm going to do is I'm going to change this for a smaller value. 25 might be too high. Let me go and find a smaller capacitor and tack it on there. I just want to put the absolute minimum capacitance in here just to stop it from oscillating. Okay, so what I did is I replaced it with a 10, and it's still not oscillating, so it's good. I'm going to check it one more time here. So that phantom voltage is now gone. I get 30 millivolts. 20-30 millivolts here now instead of the 400 or 500 millivolts. So I think that's the cure. If I turn the tone controls off, it no longer goes into protect. Okay, so looks like whatever we did worked. Now we need to get back to testing because I want to check frequency response for both channels, make sure they're both the same. Alright, so we're back on testing again. Let's try this one more time. We got an 8 ohm load, 1000 hertz tone coming in, voltmeter set up, scope set up. So let's turn this on. It's doing its protecting, timing out, clicks on, and here's our signal. Take it up to clipping. I'm not going to take it right up to clipping. We saw it doing its power thing long before. Let's take this up in frequency. That's what I'm more interested in. And we'll see how the both channels compare. So here's 1000 hertz tone going up. 2, 3, There's 20 kilohertz. Looking pretty good. Let's go up a little higher. Let's go. There's 40 kilohertz. 60 kilohertz. 90 kilohertz. 120 kilohertz. So it's doing pretty good. And our amplitude is pretty good. We're not losing anything. Okay, let's take this back down. Let's go back down. Let's do square wave. I'm not driving this very hard, maybe 10 volts on the output, so I don't want to do full power. Just want to see how this this works with our square wave. So we went up to 10 kilohertz before, I think. Let's have a look at this. It's looking pretty good. Let's keep going. That's 20 kilohertz there. So I'm confident that that capacitor I added is not going to change any characteristic of the amplifier, so I'm just going to leave it in there. It's not oscillating anymore, and if I switch out the tone controls, it no longer goes into protect. Well, there it is. It's finished. So you'll see this up on my eBay store. Get ready to bid on it. No, I'm just kidding. Now this is going back to the owner. I'm sure he's going to be happy with it. And yeah, it's quite a piece of gear. It's a really nice amplifier. I'm looking forward to doing my audible testings, and I get to listen to it. So we replaced 4 of these black flag capacitors, 14 transistors. This was my cock up, this resistor capacitor. I put that cap in backwards, which blew a resistor, fuse resistor. These are all the caps that went into it. Quite a few, well actually all of them except for the main filter caps, which worked out fine. They're performing well under full load, so I'm leaving them alone. But the rest of it is all good. And yeah, if you're going to replace transistors in tone circuits, phono stage, power amplifiers, you never know, it might start oscillating on you, so you might have to do some follow-up work on that to get that corrected. But it all worked out. It's funny though, it only happened in one channel, and the other channel was fine. So I don't know if was a defect in that channel. I don't know. I'd have to pull all the parts out and test them individually, and I don't think that's necessary. But it is working now. Yeah, so I got more stuff coming up, so stay tuned. That's it for this one. So thanks for watching, and take care.